Hi, we're group G28 and we're going to be presenting our mechanical systems project. We're going to basically guide you through the whole points we are going to cover, which will basically be introducing our project, the trust structure we've based our project in and that we've worked with, and the main goals we wanted to accomplish while doing this project, and finally the forces, how we came about to calculate all of the forces that were affecting at each one of the bars of our trust structure, and finally the conclusions we've extracted of making this project, basically. Okay. Basically what we've got to do is calculate the forces that affect at each bar. In order to do so, we've used the method of the node, which basically consists of, by drawing the diagram of each of the forces affecting at each node, we can then do the summation of the forces on both axes, y and x, and then obtain the values of that force. Okay, here you can see the trust structure we've based our project in, and you can see that it's made out of a total of 13 bars, and then it also has 8 nodes. The external forces were given by our professor, and then you can also see that in point A you've got a support, and in point B you've got a wheel. And basically that gives us in the free body diagram, which you will see now. In the free body diagram you can see that you've got 2 forces acting at point A, one horizontal and one vertical force, and then at B, since it only has wheels, you only have the possibility of having one vertical force. And then by doing the moment at point A, we can get the value of By, which equals 350 kilonewtons upwards. And then by doing the summation of forces at the vertical axis, you can see that the value of Ay is 300 kilonewtons. And then finally, by doing the same, but at the summation of the horizontal forces, you can see that the value of Ax is equal to 0, since there are no other horizontal forces affecting at this point.
So, since we are using the method of nodes, so the first node is going to be the A node. So there are 3 forces acting on the node. So we are assuming the forces are going inward, which is a compression force. So to find the angle of the theta, we are since we already know the length of C to B and A to B, so we can find by using the tangent theta, 50 over 120, and then the value is 22.62. Okay, to find the forces, by doing the summation of forces of y-axis, we can find the value of Ag, which is 780 kilonewton, in the forces compression. And by doing the summation of forces of x-axis, we can find the forces of AD, which is negative 720 kilonewton. Since it is negative, so our assumption is wrong, so it is the opposite, which is traction. Okay, the second node is the node of D. So we are assuming all the forces are outward, which is traction forces. Okay, we are using the same method. So we're finding the summation of forces of x-axis, and we can find the value dE, which is 720 kilonewton, in a forces traction. And summation of the y-axis, we got the value of GD, which is 200 kilonewton in traction.
Okay, for node G, which is here, so we draw all the forces that act on this node. Since in the previous calculation, we already know the force of AG and GD, so here we have 2 unknown forces, which is GH and GE. We assume that GH is a traction force, it is a compression force on the node G, and G is a traction force. So next, we find the angle between the force AG and GD. Since we already know that in this truss structure, the angle here is 22.62 degree. So by using the complementary angle, we know that the beta here is 67.38 degree. And we notice that here the triangle GAD is an inverted triangle to GDE. So we also know the angle here is also 67.38. and the angle alpha here, since we know here is the length 90 and here is 67.5, so we know alpha is also 22.62 degree. So here now we can use, by doing the summation of force of vertical axis and the horizontal axis, we can find our unknown forces. But here, since we have two unknown forces, so we cannot find our forces directly. So by using the method of substitution, we can find that our GH is 520 kilonewton and GE is negative 260 kilonewton. Since this GE is give us negative value, so we can know that our hypothesis here is wrong. So GE here, the force GE here is supposed to be a compression force, not a traction force. So next, note E, we also draw all the forces that act on these nodes, and here we have a GE which we find in the previous calculation, and ED, and here we have a vertical force which acting downwards, and and here we between the GE and ED, we can find the angle here is 22.62. So by using the summation of force, vertical axis, we know that EH is 250 kilonewton traction, and by doing the summation of force on the horizontal axis, EF is 480 kilonewton. Since both give us positive value, so we know that our hypothesis earlier is correct, that EH and EF is a traction force.
Okay, so after we find all the internal forces from the previous nodes, now we can proceed by finding all the forces that acting upon the node B. So here we can find that all the forces that acting on node B is force BC, the vertical force of B, and the force of FB. So in this case, we assume that the force of BC and the vertical force of BY are a compression force, and FB is a traction force. So to find out whether our hypothesis and assumptions are correct or not, we first will sum all the forces in the vertical directions to 0. Here we will obtain that the force of BC is a positive value of 350 kilonewtons. Since it's a positive value, it means that BC is a compression force, which is correct. And then we will sum all the forces in the horizontal directions to 0. So here we see that the force of FB is the only force in the horizontal directions. Therefore, FB is equal to 0. Next, for node F. In node F, first we have to find out all the forces that are acting on node F, which is here, which is FC, FH, EF, FB, and the downward force of 300 kilonewtons down here. So before we sum all the forces, we have to calculate the angle between FC and FB. Since we already know the distance and the length, we will use the method of trigonometry to find the angle, which is 59.04 degrees. And we can also use the same method to find the angle between HF and EF, which is 39.80 degrees. Since we already know all the angles that involve in node F, we can then calculate all the sum of all the forces in the vertical directions. We have two unknown here, which is HF and FC forces, and then we sum all of the forces in the horizontal directions. Since we already know the value of EF from the previous nodes, we will substitute the value of EF, which is 480 kilonewtons, into these equations, and then afterwards we will substitute the equation HF here that we obtained from the submission of vertical directions into the equations when we sum all the forces in the horizontal directions to find the value of HF. Here we find that HF is a negative value of 262.10 kilonewtons. Since a negative value, it means that our assumption is incorrect. HF is actually a compression force. And since we already know the value of HF, we then substitute the negative value of HF into this equation to find the value of FC. FC force is a positive value of 545.5 kilonewtons with the angle of 59.04 degrees. Since the positive value, Fc is a traction force.
Okay. Once again, we calculate the forces acting for node H, and we get that the only unknown value we have left is Hc. First, once again, what we do is calculate the angles that each of the forces make with at point H. For example, the angle theta here is the one made out from H, E, and F, and since we know the values, the length and the height, we can calculate the angle. We do the same for the angle alpha, which is this one over here, which is made out of point H, C, and the middle part of the bar CB. And then finally, since we know the angle that this triangle makes, points G, H, and the middle part of H and E, we know that this angle over here is 22.62, and we know that it's a complementary angle with this one. So we simply subtract 90 to that angle, and we get that it is 67.38. And then finally, to calculate Hc, we simply do the summation of the forces at the vertical force, and we get that Hc is 306.2 kilonewtons, and it's a compression force on node H.
For the last node we are going to calculate is the node C. We are calculating this node just to confirm that our previous calculations are correct. So, since we have already know all the values and all the type of forces in the previous calculation, we can now just put all the forces that are acting on the point C, it's here, into its real direction. So HC and BC is compression forces, and FC is the traction forces, and we now have to find the angle of beta. So 90 minus the angle theta, which is 59.05, and we got the angle is 30.96. And now to find the angle of alpha right here, we can use the trigonometry method, which is 25 over 60, we can which is 22.62. Okay, to find the forces, the value of the forces, we do the summation of the forces of the y-axis, and we can substitute all the forces that we got in the previous calculation. We got the value is Hc, which is 306.2 kilonewton, and it is a compression. So yeah, it's right, and the value is the same with the previous calculation that we have made. So this conclude that our previous calculations are all correct, because we have the same value.
Since we already done the calculation in node C, it's now proven that our calculation is correct. So this is our summary from all the calculations that involved when we find the internal forces and the state of each forces, whether or not it's compressions or traction. Therefore, we have achieved and obtained our objectives perfectly. Thank you.